So let's increase the size of the scene by another factor of 100. So we were at about 1,500,000 kilometers. Now, if you increase that size by a factor of 100, you will now be dealing with a view that is 150 million kilometers wide. And on this scale, we see not just Earth, but also two other inner or terrestrial planets, Venus and Mercury. So our distance from the sun is 150 million kilometers. Now I want to point out one thing, that if you look at any astronomy textbook or website where the attempt is made to show the planets in a way that portrays accurately their relative size and also their relative distance, that is not possible. Because if you get the sizes right, as it is the case here with Earth, Venus, and Mercury, then the distances between the planets and their distance from the sun, they don't come out right. And the only way to actually get everything right is to build a model of the solar system. And I urge you to view an excellent video called To the Scale, which shows the solar system to the scale that I've linked under the study aids. It's made by a group of young fellows, and they did a fantastic job. And what they've done is the only way to actually get all the relative distances and sizes correctly. Okay, so the average Earth-Sun distance is 150 million kilometers. Now we can write 150 million using scientific notation. 1 million is 10 to the power 6, 1 followed by 6 zeros. But then 150 million is 1.5 times 10 to the 8, right? 1.5, and then I have to multiply that with 10 raised to the power 8. So this is what is known as scientific notation. But you see, when we are when our viewing field is such that we are looking at the distances of planets from the sun, the numbers that we need to express the distances become very large. So that signals that maybe to express the distances within the solar system in more natural way, we need to abandon kilometers, because if we stick with kilometers, we would be using very large numbers, and use another yardstick to measure the distances in the solar system. And the natural yardstick would be the distance between the Earth and the sun. There are other choices. One can, if one lived on Venus, one could take the distance between Venus and the sun, but because we live on Earth, for us it's more natural to take the distance between the Earth and the sun to measure the distances in the solar system. And that new yardstick, the average distance between the sun and the Earth, is known as 1 astronomical unit, or AU for short. Now, so 1 astronomical unit, by definition, is the average Earth-Sun distance, or if expressed in terms of kilometers, 150 million kilometers. Now, why do I talk about the average Earth-Sun distance? Turns out that the Earth's orbit around the sun is not perfect circle. Sometimes it is closer to the sun, and that happens around the Christmas time or around winter solstice now. And sometimes it is at a greater distance from the sun, and as it happens, the Earth is at the greatest distance from the sun at the beginning of July now. But this variation in the distance between the Earth and the sun is very small. It's under 2%. It's actually 1.7%. Nevertheless, we have then to talk about the average distance between the Earth and the sun, because that distance is varying slightly. So that is the definition of astronomical unit, and it's 150 million kilometers. So now we can ask the same kind of question that we asked before when we pondered how long it takes the sunlight reflected off the surface of the moon to reach us here on Earth. We can ask how long does it take light emitted by the sun to reach the Earth at a distance of 1 astronomical unit, 150 million kilometers. Again, the principle is the same. We divide our distance from the sun, that is 150 million kilometers, with the speed of light, which is 300,000 kilometers per second, to get the time. So when you do that, you can do this without using calculator. It's basically like 1500 divided by 3, which is 500. So it takes 500 seconds for light emitted by the sun to reach us here on Earth at a distance of 1 astronomical unit away from the sun. Well, keeping in mind that 1 minute has 60 seconds, 500 seconds is equal to 8 minutes and 20 seconds, or about 8.3 minutes. So again, if you take a peek at the sun, but just take a peek, otherwise you can damage your eyes, the sunlight that you see, or the image of the sun that you see, is not how the sun looks right now, where now is defined by your watch. You see the sun as it looked 8.3 minutes ago. So now we have bigger distance, and this time it takes light to travel that bigger distance is longer. So remember, as I said earlier, that the greater the distance, the longer is the look-back time. So then we can introduce yet another unit for distance, the light minute. That is the distance light travels in 1 minute. Therefore, we can express 1 astronomical unit, the average distance between the Earth and the sun, in terms of light minutes as 8.3 light minutes, because it takes about 8.3 minutes for the light that leaves the surface of the sun to reach us here on Earth.